Hey guys, this is Joseph from startdataengineering.com. In this video, I'd like to talk about two of the most popular data processing paradigms, ETL and ELT. And as always, if you'd like to follow along in the blog format, I'll leave the link in the description below. So let's get started. First, let's define what these alphabets stand for. E stands for extract, which refers to the process of extracting data from the source system. And the source system could be anything. It could be a application database. It could be your data vendor's files on S3. T stands for transform, and it is a wide term which refers to any type of transformation or any type of processing that you do on the raw data to change its form in one way or another. For example, it could be as simple as joining with other tables in your data warehouse, or it could be running machine learning models and populating feature columns, or calling external services to enrich your data. And finally, L stands for load, and it refers to the process of loading data into the table that is going to be used by your data user. So let's start with ETL. As the name suggests, ETL stands for extract, transform, and load. And these are the steps in order. The first step, you extract data from a data source. You store it in a staging area. If you're unfamiliar with why we use a staging area, you could follow another link in the description below, which explains what staging area is and why we need it. And the third step is doing some sort of custom transformation. This is generally a script using Python, Scala, Spark, or Flink. And then you load the transform data into a table that can be used by your data users. So let's look at two of the most common types of ETL. Type 1 is batch ETL, which refers to running this data pipeline as a batch, meaning every scheduled interval. It can be like an hour, it can be 30 minutes to a day, a week, whatever is your constraint. So as you can see, you have multiple data sources. You extract them into a staging area. In this case, we have used S3 file system as a staging area. And then you run a transformation script, most commonly Spark or Python or Scala script, and then you load the transform data into your data warehouse, and now the data is ready to be consumed by a data user. Another type of ETL is streaming ETL, which works on unbounded input data, meaning you get data from multiple sources pushed into a Kafka queue, which is pushed generally to a S3, and you have a streaming service that reads continuously from this S3 file and does some processing. This is generally done using Spark Streaming or Flink. And based on how you're implementing it, either micro batches or individual records, you transform it and you load it into a data warehouse. So that's streaming ETL. So let's look at the second paradigm, which is ELT. And as the name suggests, stands for extract, load, and transform. The idea is you extract and load data from your data source system directly into a data warehouse table. And these tables are generally called staging tables. And the second step, which is the transform step, would be to run a native SQL script to transform those stage data into the desired shape or format that you need for your end users. So let's take a look at an example. So this is the same paradigm for streaming and batch ELT, because both follow the same pattern. You have your source, you pull data from that source, you load it into a staging table, and then you run some transformations on the staging table. It can be joining, it can be grouping by certain parameters, it can be some custom business-based logic, and then you load it into the final table, and this table is ready for use by your data users. So this is ELT paradigm. So let's do a quick comparison of ETL and ELT. So let's start with ELT. It has low number of components, which means it's easier to maintain, lesser number of components that can fail, so less to monitor, and it's generally less expensive than ETL, although it heavily depends on how you set up your system. And it can also work with standard encoding formats like Parquet, ORC, because most data warehouses are able to load Parquet and ORC type files, although schema evolution may be a little bit tricky. So now let's look at ELT type systems. So ELT type systems are great when you have non-standard file types like zip files or vendor-specific files. Some data vendors have their own standardized, serialization formats. In those cases, ETL is the way to go because you cannot deserialize them within your data warehouse. The next point would be running machine learning algorithms. So in ETL, you can train machine learning algorithms. You can do probabilistic matching and things, natural language processing, and things like that, and also image processing. But in ELT, this is not always possible. Although there are some very little machine learning capabilities in some data warehouses, it's almost always preferable to follow a ETL pattern when you're doing some machine learning algorithms. The next point is accessing external services. For example, while you're processing the data, let's assume you want to hit a third-party service or some other service, even within your company, to enrich that data. You need to do a ETL type system because you cannot access data from a third-party service in an ETL type paradigm. The last one is dealing with non-tabular structure. So for example, if you're parsing out some sort of graph data, you definitely need an ETL type system. This cannot be done in most cases with the ELT type system. So let's look at some more points. So as you can see, ETL is more flexible, but ELT has been gaining a lot of popularity because the data warehouses have been getting very powerful and also cost effective because of the separation that they offer between storage and processing in terms of external tables. So you can actually store your data in S3 or cloud storage, and you can write query on top of the data in S3. This makes storage much cheaper, and processing, you're only charged for the data you scan. So ELT has been, and with ELT you have less number of components to manage, and it's less engineering effort, and that's why ELT has been really popular recently. You could notice tools like dbt that are focused solely on ELT type pipelines. But there are cases for using ETL as well. So for example, as we mentioned earlier, running machine learning algorithms or accessing data from a third-party service that's not present in your data warehouse. Again, as we mentioned earlier, data warehouses are getting powerful features like external tables, separation of query and storage. And because of these, the definition or separation of ETL and ELT is getting difficult because in most cases it's a combination of both. So let's look at an example. Let's say you have a data pipeline in which you have to run a machine learning model and then join the result set with data present in your data warehouse. So you will extract data from your data source. You will run a machine learning model, let's say in a simple Python script, and fill up some, let's say, feature columns. And then you load that table into a data warehouse table. So you load that data set into a data warehouse table, and then you do the transformation, which is joining to other tables within the data warehouse, and then you load it into a final table ready to be used by your data user. So technically, this will be called the ETL pipeline, but in most cases, people just call it ETL pipeline. And recently, ELT has been used to denote a process where the transformation occurs only within the data warehouse. Having said all that, the key idea that I want you guys to take away from this video is to start simple and try to keep your data pipelines, the number of components in your data pipelines low, and add complexity as your data needs evolve. The reason for this is if you keep your data pipeline simple, you can deliver results faster and you're not over optimizing prematurely. So that will help you scale faster. I hope this video has been helpful in understanding what ETL is, what ELT is, and what their differences are, and how you can use those concepts to build scalable and efficient data pipelines. If you like this video, please like, share, subscribe. It really helps me out a lot. I'll see you all next time. Thanks for listening.